Hello, welcome to our first video of the course. So we're going to explore what it means when we talk about machine learning. So what exactly is machine learning? Let's borrow Mitchell's textbook definition. So Mitchell mentions that a well-defined learning problem requires three things. The first thing is a well-defined task. The second thing is a well-defined performance metric. And the third thing is a source of training, some sort of knowledge. So some sort of training or experience where the learning problem could learn from. Let's explore a little bit more on those three key points. First, the task can be thought of as a function, a mathematical function, where you have one or more inputs and you have an expected output. So for instance, if you have a function that would predict what the price of a house would be given some information on, let's say, the city, the state, the size in number, the number of bedrooms, the square feet of the house. So all those information could be used to be used as inputs to that function, and then the function would be outputting a prediction that, in this example that I just gave you, would be the price of the house. Second thing, a metric means that we want to have a way to somehow measure how well our algorithm is actually doing. So if you are, again, using the same example, predicting the price of the house, and you have access to actual house prices, you can compare the prediction against the actual prices that you have. So if we use some metric, for instance, we could just verify what the delta would be between the prediction and the actual price. So that would be one example of a very simple metric that you could use to estimate how good the model is doing. And third, we need to have some sort of training experience. So the ubiquitous example is when you have data available that would be used to essentially make the model learn from that data. So if you have historical data, the model would be essentially trying to align against that data. And then by aligning to the data, to some degree, we expect the model to do well. So let's try to visualize a little bit more on that. If we would say that our task has as we mentioned before, a sort of an input and an output. So the idea of a function, we could list a few examples of tasks that would be associated, that would be essentially acting as those functions that would be taking inputs and generating some possible outputs, possible responses. So for instance, you might be just selecting between two choices, might be like the yes and the no, the true and the false. So essentially the typical binary classification problem. You might be selecting from a sequence of actions, so not one single thing, but actually a sequence of actions that would need to take place. So for instance, if you are trying to predict what an autonomous vehicle should do next, that's not one single thing, but actually a series of things. So maybe you need to tilt by a number of degrees to the left, the wheel, and then accelerate, or maybe reduce the speed, and then so on. So depending on essentially a number of factors, you would the model in that case would need to be selecting among a series of different actions. Another example that we have would be scoring the relevance of documents. For instance, when you do a web query, so the most popular example is when you are using some sort of a search engine like Google. You would be using some sort of input, and then you would want as response the related documents or websites that would be most relevant to the keywords that you have used, right? So that would be a sort of a scoring, some form of score that could be used to essentially rank how relevant a given document or a given web page would be. And one last example would be to infer some form of structure. So in this example, if you have a handwritten picture of a handwritten mathematical formula, you could actually have a model infer the underlying structure of that formula. So in terms of the function itself, if we have a decision function, usually we have some parameters that would be used by the function to gradually learn how it would essentially do the prediction. So we differentiate between parameters and hyperparameters. Parameters are essentially the parameters that would be learned by the model itself. Hyperparameters would be parameters that are defined by the practitioner, by the person that would actually be setting up the given model. So a hyperparameter is not typically something that would be learned autonomously by the model, while the parameters would be actually the numbers, the coefficients that would be learned. And then we have the performance metric that would be acting as a sort of a loop to determine how well essentially our model is doing. In order to actually estimate that performance, you need to rely on some existing examples, some existing data. So that usually is referred to as training data, because the model would be trained using that data to find ideally the optimal weights or parameters to perform optimally. So when we say learn, the term learn means essentially that we would be looking for the optimal set of parameters that would make my model perform the best. So I'm essentially trying to make my model evolve on the search for that parameter values, and by doing that, we expect the model to do gradually better until you find the optimal set of coefficients or parameters. So as we said, we have this definition from Mitchell, and in a sentence. So a computer program is said to learn from experience E with respect to some class of tasks T, and by using a performance measure P in its performance at the task T, as measured by P, to improve with the experience E. So that's one way to approach that definition. In an alternative definition that I actually like it a little bit better is that a learning problem can be thought of as an optimization problem. So now we use the framework of the optimization, meaning that we want to optimize some values, some variables, some parameters. And we are calling that optimization algorithm E, fitting parameters on a decision function F designed for that same task T, by using the same performance measure or metric P, and by using the training data or that comes from the experience. So here we are being a little bit more explicit on how actually the knowledge experience is coming from. So it's really just coming from the data that is already available, the training data that you have access to. So we mentioned that the machine learning model would be one way to think about it, would be in the framework of the optimization, right? If we want to optimize, this means that we want to find the optimal or the set of optimal values for our parameters. So this can be thought of as exploring or navigating a parameter space. So we can also explain or define that process as a parameter space search. So in a way, you can also think of that as navigating in a high dimensional space where your parameters live, and you are essentially just trying to find the point in that high dimensional space that essentially is the combination of all the parameters that you have that would make the model perform the best. So ultimately, we want to tune or find the best values for our function parameters. That's what's going to be learned. And we also want to find the best working values for the hyperparameters. That would be the parameters that would be actually something that we would manually fix. So one example of a hyperparameter would be, for instance, in a K nearest neighbor classifier. That would be one of the models that we would be exploring. We need to specify the K value. The K essentially means how many points you are considering in the neighborhood of a given point to perform your classification task. A similar idea exists in a clustering algorithm called k-means. So you also determine the k in the k-means clustering algorithm, but in a different approach, where you would actually be choosing the number of clusters that would be existing in your input space. So these are two examples of hyperparameters that would need to be set most of the time by ourselves, by the person that is setting up the machine learning model. All right, that concludes our introduction on what machine learning is, and I will see you on the next video.